These are the engineers who think they've solved the 60-year-old puzzle that killed the rotary engine. They're betting everything that their new designs will revolutionize transportation at the exact moment electric vehicles are taking over the world. The rotary engine has always been the automotive industry's beautiful failure. Felix Wankel invented it in 1957, and it promised to change everything with 75% fewer moving parts than a traditional piston engine. Instead of pistons pumping up and down, a triangular rotor spins inside an oval chamber, creating power with buttery smooth operation. For decades, only Mazda kept the dream alive with their RX series sports cars. But in 2012, when the last RX-8 rolled off the production line, it seemed like the rotary engine was dead forever. Now, something unexpected is happening. In the last 2 years, a wave of startups and established companies have suddenly started pouring millions into rotary engine development. The U.S. Army just handed LiquidPiston a $30 million contract in January 2024. Mazda shocked everyone by putting a rotary engine back into production with their MX-30 REV in 2023. Astron Aerospace revealed their Omega-1 hydrogen rotary in March 2024. Companies like Aquarius Engines and INNengine are racing to patent their own revolutionary designs. Why now? Why are these engineers convinced they can succeed where decades of attempts failed? And what makes them think they can compete in a world where electric vehicles already captured 18% of global car sales in 2023? The answer starts with understanding why rotary engines failed in the first place. If you owned one of those Mazda RX-7s or RX-8s, you know the heartbreak. These engines guzzled fuel like they were dying of thirst, burning 20 to 40% more than comparable piston engines. They consumed oil at an alarming rate, typically going through a quart every 1,000 to 2,000 miles. The apex seals, those critical components that separate the combustion chambers, would wear out around 80,000 to 100,000 miles, and the emissions, high nitrogen oxide and hydrocarbon output, made them environmental nightmares in an era of tightening regulations. But here's what the new generation of engineers realized. Every one of those problems stemmed from trying to make rotary engines work like piston engines. They were using the wrong fuel, the wrong applications, and the wrong expectations. The breakthrough came when they stopped trying to fix the old problems and started exploiting the rotary's unique advantages. Take LiquidPiston, founded by the Skolnick brothers, Alexander and Nikolai. They flipped the entire design inside out with their X-engine technology. Instead of a triangular rotor in an oval housing, they use an oval rotor in a triangular housing. This seemingly simple change addresses the fundamental efficiency problems that plagued traditional rotaries. In 2020, they demonstrated 70% thermal efficiency in laboratory conditions, and that's better than any production car engine and approaching the theoretical limits of internal combustion. We're not trying to compete with EVs, we're complementing them, Alex Skolnick explained in a recent interview, and that's the key insight driving this rotary renaissance.
These engineers aren't trying to replace your Tesla. They're targeting applications where batteries struggle. Consider the military's interest. That $30 million contract LiquidPiston received, it's for portable generators that soldiers can carry into the field. A traditional generator that produces 1 kilowatt of power weighs about 40 pounds. LiquidPiston's rotary design delivers the same power at just 4 pounds. When you're carrying equipment through hostile territory, those 36 pounds matter. The engine runs on multiple fuels: gasoline, diesel, jet fuel, whatever's available. Try doing that with a battery that needs specific charging infrastructure. But the real game changer might be hydrogen. Mazda's engineers discovered something crucial. The rotary engine is ideal for hydrogen combustion, as one of their engineers stated in 2023. The rotary's combustion chamber shape and longer burn duration solve the pre-ignition problems that make hydrogen difficult to use in piston engines. Astron Aerospace's Omega-1 takes this to the extreme, a hydrogen-powered rotary that they claim produces near-zero emissions. This is where the story gets interesting. While Tesla and other EV manufacturers are building massive battery factories, these rotary developers are preparing for a different future. They're betting that the world needs more than one solution to transportation.
Look at Mazda's approach with the MX-30R EV. It's not a pure rotary car, it's an electric vehicle with a small rotary engine as a range extender. The rotary doesn't drive the wheels, it generates electricity to charge the battery. This solves the EV's biggest weakness, range anxiety, while keeping the smooth, quiet electric driving experience. The rotary only kicks in when you need extra range, running at its optimal efficiency point. The numbers tell a sobering story about the EV revolution. Yes, 14.2 million electric vehicles were sold globally in 2023. Yes, the International Energy Agency projects EVs will capture 60% of new car sales by 2030. Battery costs have plummeted 90% since 2010. The momentum seems unstoppable. But dig deeper and cracks appear. The electrical grid struggles to handle rapid EV adoption. Charging infrastructure remains spotty outside major cities. Battery production depends on lithium, cobalt, and rare earth elements with problematic supply chains. Cold weather can slash EV range by 40%. For many applications, long-haul trucking, aviation, marine transport, remote power generation, batteries simply don't work. This is the opportunity these rotary engineers see. Not killing the electric vehicle, but filling the gaps batteries can't reach. Consider the aviation angle. Batteries are too heavy for aircraft. Every pound matters when fighting gravity. But a compact, lightweight rotary engine running on hydrogen or sustainable aviation fuel, that could work. Several companies are already developing rotary engines for urban air mobility vehicles and drones. Or look at backup power generation. When the Texas power grid failed in 2021, EV owners couldn't charge their cars. But a small rotary generator running on natural gas or propane could keep your home powered for days. The compact size means it fits where traditional generators can't. The marine industry presents another opportunity. Electric boats work fine for short trips, but crossing an ocean on battery power isn't realistic. A hydrogen rotary engine could provide clean, long-range propulsion for ships. Even in automotive applications, rotary engines might find new life in unexpected places. Performance enthusiasts have always loved rotary engines for their high-revving character and unique sound. What if future sports cars combine electric motors for instant torque with a high-revving rotary for extended track sessions? But let's be honest about the challenges. 60 years of failure cast a long shadow. Those apex seal problems? Still not completely solved, though new materials and manufacturing techniques show promise. The efficiency improvements? Impressive in labs but unproven in mass production. The hydrogen infrastructure? Even less developed than EV charging networks. The biggest challenge might be perception. Mention rotary engines to anyone who owned an RX-8 and they'll tell you about endless trips to the mechanic. Convincing consumers to trust a technology that burned them before won't be easy. There's also the uncomfortable truth about market dynamics. The automotive industry has invested hundreds of billions in electrification. Major manufacturers have announced end dates for internal combustion production. Entire supply chains are reorganizing around batteries and electric motors. A few startups with clever rotary designs can't reverse that momentum. Some claims circulating about these new rotary engines deserve skepticism. Despite what clickbait headlines suggest, there's no evidence Elon Musk has commented on any specific rotary engine development. Claims about revolutionary efficiency breakthroughs that will end the EV era are marketing hyperbole, not engineering reality. Most of these new rotary engines target hybrid systems or specialty applications, not direct EV replacement. So where does this leave us? The rotary engine story isn't about defeating electric vehicles, it's about finding its place in an electrified world. These new developments suggest that place might be larger than anyone expected. The military applications seem most promising in the near term. Portable power generation, unmanned aerial vehicles, and auxiliary power units benefit from the rotary's power density.
Hydrogen combustion represents the biggest wildcard. If hydrogen production becomes cheap and clean through renewable energy, hydrogen rotaries could provide long-range, zero-emission transportation for applications where batteries struggle. But that's a big if, depending on infrastructure development that makes EV charging look simpler by comparison. Range extenders for electric vehicles offer a pragmatic middle ground. Drivers get the benefits of electric propulsion for daily driving while maintaining the flexibility of liquid fuels for longer trips. It's not revolutionary, but it might be revolutionary enough. The real lesson here isn't about rotary engines or electric vehicles. It's about the danger of technological absolutism. The future of transportation won't be all electric any more than it will be all rotary or all hydrogen. Different applications demand different solutions. Urban commuters might thrive with pure battery electric vehicles. Long-haul truckers might prefer hydrogen fuel cells. Remote communities might depend on multi-fuel rotary generators. Performance enthusiasts might choose hybrid rotary electric sports cars. The winners will be companies that recognize this diversity and develop appropriate technologies for each niche. The engineers resurrecting rotary engines understand this. They're not trying to recreate the past or stop the future. They're recognizing that a technology's failure in one context doesn't mean failure in all contexts. By reimagining what rotary engines could be, range extenders, hydrogen combustors, portable generators, aviation power plants, they're writing a new chapter for a technology many consider dead. Will these new rotary engines end the electric vehicle era? No. That headline is nonsense designed to generate clicks, not inform readers. Electric vehicles are here to stay, and their adoption will continue accelerating. But will rotary engines find new life in an electrified world? The evidence suggests they might. The $30 million the Army just invested says they see potential. Mazda, putting rotaries back in production, says they see opportunity. The venture capital flowing into companies like LiquidPiston and Astron Aerospace says investors see possibility. Whether they're right depends on execution, infrastructure development, and market dynamics beyond any single technology. What we're witnessing isn't the end of the electric vehicle era. It's the beginning of a more nuanced understanding of transportation's future. Battery electric vehicles will dominate urban and suburban driving. But for the edges, the long distances, the remote locations, the specialized applications, there's room for other solutions. Some of those solutions might spin instead of pump.
The rotary engine's greatest weakness was always its inflexibility. It needed to run at high RPMs, couldn't handle varying loads efficiently, and struggled with emissions at partial throttle. But in applications where it can run at constant speed, like generating electricity, those weaknesses disappear. In applications where power density matters more than efficiency, like aviation, its strengths shine. That's why these engineers are betting everything on rotary engines now. Not because they're delusional about defeating Tesla, but because they see opportunities in the gaps. They see a world that needs more than one answer to transportation. They see applications where spinning triangles might work better than battery packs. The beautiful failure of the rotary engine might finally have found its moment, not as the universal solution Felix Wankel envisioned, but as a specialized tool for specific problems, not as the star of the show, but as a supporting player in transportation's electric future. After 60 years of searching, the rotary engine might have finally found where it belongs, not replacing electric vehicles, but working alongside them to create a more flexible, resilient transportation system. The engineers pouring their careers into these new rotary designs aren't trying to turn back the clock, they're trying to expand our options. In a world facing climate change, energy security challenges, and diverse transportation needs, we need all the options we can get, even if some of them spin in ways that seemed obsolete just a few years ago.